Assalamualaikum warahmatullahi ta'ala barakatuh. And good day to each and everyone. Okay, so last meeting, we have already have our prelim exams. Okay, so this means that we are on top of these semesters, no, to finish this course. Okay, so where we were try to further do our best in order for us to learn this concept, no, learn all the concept that is being included here as much as possible. Okay, so last meeting, no, we have also discussed the some basic concept and idea about how we can simplify a circuit calculation in order to simplify, or in order to use it to simplify the circuit or complex circuits. Okay, so for now we will continue that discussion, and of course we will be uh, going towards this discussion for some continuation of these topics. Okay, and having these so to have this continuation of this subject, no, so we have these topics. Okay, so we have here the first order circuit that is being included here, the uh, source free RC circuit, which is the resistance and capacitor circuit, no, in series. The source, whether it is in series or parallel, so included na dyan. The source free RL circuit naman, resistance and inductance, same with this resistance and capacitance. Then singularity function, then step response of an RC circuit, and step response of an RL circuit. Okay, so what shall we have here? No, so uh, throughout this discussion, you will know that series RC circuit or series RL circuit will have a response on a circuit. No, if you have to um if you have to connect that one in series with the source, then it has a response to a certain circuit, no, at a certain time interval. Okay, so it means that it will have a supply, or it will absorb during when it is connected in series with the source, and it supplies when it is connected to a load, okay, for a certain time. So that is a basic characteristic of having these circuits. Okay, so we have here the first order. Okay, so we call this one the first order. It's because if we connect this R and C circuit, okay, the equations that will be conducted, no, or that will be found out will be first order. Okay, so we call that one as a first order. Okay, so we will not I will not be having to read this one, but yeah, I will let you to have that one to read that one. Okay, so we just have to continue further on our examples. Okay, so ito na lang muna, no, make sure that you will know about how to derive this equation, kasi throughout this problem, all we have to use is this one, okay? These equations here, these final equations, and this is the derivation. But some problems included here is having varying its characteristics. So in order, when the circuit is varied, okay, in terms of its characteristic, you will no longer use these equations here. No? So ibig sabihin, going you will be starting from these equations, basic equation, then you will derive another equations, okay, that is related with that variation of characteristics. Okay, so but some of most of the situations is actually uh, plug in lang naman. Okay, so you will just have to use these equations, and you can get the final answers. Okay, so natural response. Okay, so for single cir- uh for a linear circuit, no, a combination of RC or RL circuit, it has a response of this kind of graph. Okay, so it means that if it is charged, or if it is connected in series with a source, okay, then suddenly you will connect it into a load, so its source to will go like this, like this graph. Okay, so it will go downward, no, and will continue to go downward, and will follow this graph. Okay, so ito yung tinatawag natin natural response. Okay, so kung makikita natin, no, ni-label niya rito yung equations natin dito. Okay, so it means that these equations, no, if you follow these equations, the graph that will be generated is like this one. Okay, so what is time constant? So time constant is this one. Itong tau dito, no, yung nakita nating tau. Yan yung tinatawag nating time constant. So that is very important kasi it is depends on the value of RC or RL that is being connected. Okay? So nakadepende lang yung tau natin doon. Okay, so as you vary the time, no? As you vary the time, yung t rito sa numerator, as you vary that one, okay, this whole value is also varying, no? Just also varying and follow this graph, okay? So yun. So we have here an example, okay? So please read this uh K idea or K working in source free RC circuit, no? So when you're working for source free RC circuit, this is the very important condition that you will follow. Okay, so itong dalawang condition na to, so please read that one. So example number one, so we have here, let VC of 0 is equals to 15 volts. Then find VC, Vx, and Ix for t that is greater than 0. So what do you mean by this one? This is the voltage of the capacitor at time t is equals to 0. No? So it is equal to 15 volts. Then you will ask to find the VC, Vx, and Ix. Okay, at t that is greater than 0. Okay? So ito yung circuit natin. So the 8 ohm and 12 ohm resistors in series can be combined to give a 20 ohm resistor. So ito no. So we have to combine this one, okay, in order to simplify this circuit. So and para then after we combine this one, no, it is in parallel with the 5 ohm resistor, okay? Then the result will be this one, okay? So we have to combine this combination of these two resistor here and in combination with this 5 ohm kasi nga parallel sila, then this will be the result, no? Then after that, we have to find the tau constant or the time constant, okay? It is equal to R equivalent multiplied by the capacitor. Then this is equal to this one, no? So after that, by using this equation here, using that equation, we can now find the voltage across the capacitor at time t is equals to 0. Okay? So, ito yun siya. Itong equation natin. So, this is the initial voltage. Then, at time t is equals to, this would be the equation of the free RC circuit. Okay? The free RC circuit. Then, substituting the value of Vx, okay? Then, finding Ix, okay? But using this equation muna, no? Okay, then finding Vx, then we can now find this one, no? This equation. Then, after that, substitute the value, then finding Ix, so we have Vx over 12, so we have this equation, okay? So, uh, it means that Ix, Vx, and VC are all function of time that follows these kinds of graph here. Okay? So, yun yung findings natin dito. Okay? So, we have here a practice problem. So, please answer this one. Okay? So, we have here another example. Okay, so we have here, refer to the circuit here, then assuming that VC at time t is equals to 0 is equals to 30 volt, then determine VC, Vx, and I sub O at t that is greater than or equal to 0. So, same pa rin yung sa taas, no? Same pa rin yung sa taas. Ay, practice problem pala to, no? So, dito tayo sa example number 2. The switch in the circuit has been closed for a long time. So, ibig sabihin, this is switch on at long time. Okay? So, naka-close to siya at long time. So, ibig sabihin, originally, this is being connected. Then, it is open at time t is equals to 0. Then, the question here is find V of t for t that is greater than 0. Then, calculate the energy stored in the capacitor. Okay? So, in order to find the energy, find the energy, in order to find the energy stored in the capacitor at time t that is greater than 0, we must have to find the value of find the value of voltage across capacitors kasi nga siya yung magsusupply rito sa kuha natin, 'di ba? Kasi at time t is equals to 0, gi-open natin to siya. So, ibig sabihin, this part here is already isolated, no? From this part here. So, ibig sabihin, kung connect natin, gi-open natin to siya, this source here will no longer supply this load here. Instead, the capacitor will supply some energy here sa dalawang resistor na to. Okay? So, yun yung ibig sabihin nun. So, at time t is equals to 0, we have the voltage across the capacitor is um, 9, 9 plus 9 over 9 plus 3 at 20 so voltage division pala to, no? Voltage division. So uh, we have here VC of t is 9 over, so division dito, no? This is at naka-connected pa siya, no? Naka-connected pa yung source dito. So the voltage here is given by this voltage division, no? So we have here 9 ohm over 9 plus 3 ohm multiplied by the source voltage 20 volts. So that is the voltage across the capacitor when this switch here is closed at time t is equals to 0, no? So at time t that is greater than 0, we open that one. So ibig sabihin, ito lang yung remaining sa circuit natin, no? So sabi dito, since the voltage across the capacitor cannot change instantaneously at time t is equals to 0, okay? Towards at time t is greater than 0, so ibig sabihin, constant din siya at instantaneously. So ibig sabihin, hindi siya mag-fluctuate. Okay? So the capacitor at t is equals to 0 negative is the same at t is equals to 0, or VC of 0 is equals to V sub O is equals to 15 volts. So we have here R equivalent here, no? Diba, as I have said, na isolated na to. So hindi na to, wala na tong gagawin sa circuit. So ito lang muna yung remaining natin. So R equivalent is 9 plus 1. Okay? So then tau natin is R equivalent multiplied by C. So that is equals to 0.2 seconds. Okay? Then we have here the 15 we have here the equation. Okay? Then after that, we have the formula for energy is equals to 1 half CV squared. Then where our VC sub O squared is this one. So after that, makukuha na natin yung equation. Okay? Or the value of energy at time t is equals to 0. Okay? So yun. Okay, so as you can see here, ito yung minimin ko na circuit at time t is equals to 0, where the switch is being disconnected. Okay? So nung hindi pa siya na-disconnect, ito yung original natin na circuit, no? So nung na-disconnect na siya, itong source na to at saka yung 3 ohm na yan, ito na yung circuit natin. Okay? So yun yung ibig sabihin ng problem na to. Okay? So we have here also a practice problem. So please go on through this equation here, practice problem here. Okay? So